Hello, Beaufort Middle School students. This is Mrs. Brigman, and I want to welcome you to the first lesson of Unit 5, Part 2. And today we're going to be talking about angles and classifying special types of angles. Before we start, please find your guided notes. Make sure you are filling in all the vocabulary words. There are several vocabulary words throughout this lesson that are very important, and they will be extremely important throughout the unit. So please make sure you have your guided notes ready to go. Another thing I would like to encourage you to do is to please copy any examples that you see me completing on the screen. Copy those in your notes. And also, you're going to find a lot of these vocabulary words you already know, and that's great. But there are also some new ones that are kind of challenging. So what we would like for you to do is get a piece of notebook paper, and throughout the lesson, if there are any questions that you have, please make a bulleted list on that notebook paper of the questions that you have, and we would like for you to ask your teacher these questions tomorrow in class. So please come prepared tomorrow with some questions to ask your teacher on the concepts that are presented to you in this lesson. Alright, please find your guided notes, and we're going to start with our first vocabulary word, which is an angle. And you can see down below the picture your definition for angle. An angle is formed by two rays with a common endpoint. The common endpoint is called the vertex. Angles are going to be classified by their measures, and that's what we're going to talk about today. Angles are also notated with letters, and you can see in the picture the notation A is read angle A. You will also notice that the notation with a lowercase m and the symbol angle as seen here in your notes down below. This would be read the measure of angle A. Now in our example we see a gymnast, and this is a 90-degree angle, and it's indicated by the little box that's here in the corner. And we know that it's labeled A because we see the A right here at the vertex. The next slide is going to have a video, and I want you to watch the gymnast as he performs on the rings and notice all the different types of angles that he is creating with his arms.
Has a very good look with his gymnastics, but has at times had difficulties in putting together an entire optional competition. So far, he's been real good, though.
If you just joined us, we are live here at the Fleet Center in Boston at the men's Olympic gymnastics trials.
This is great. Watch this right here. Oh! Wow. He barely got that around, John.
This is the last pre-event before the Olympic Games, which of course are in 3 weeks. We are deciding the top 7 men out of 14 here on the gym floor who will go to Atlanta. Cheney's Florex a 9.25. So it seems that scoring Florex a little low.
Little tight on floor. Dismount. Well, he does what you have to do.
Alright, great. Hopefully from that example you noticed many different types of angles, and those are the types of angles we're going to talk about today. So I'm going to go through this first page of vocabulary pretty quickly, so please grab your notes, and if you need to press pause at any time, please do so. The first type of angle we're going to discuss is an acute angle. An acute angle is an angle whose measure is less than 90 degrees. The second type of angle we're going to talk about is an obtuse angle, and this is an angle whose measure is between 90 and 180 degrees. So it is larger than a 90-degree angle, but less than a 180-degree angle. We're now on number 4 on your vocabulary list. A right angle is an angle whose measure is exactly 90 degrees, and the gymnast did a really good example of creating a 90-degree angle with his body on the rings exercise. When you are working with right angles, the box in the corner indicates the right angle. And number 5 on your vocabulary list, a straight angle, and this is an angle whose measure is exactly 100 degrees. All straight lines have an angle measure of 180 degrees. Alright, moving on to number 6, complementary angles. Two angles that are complementary if the sum, so you need to fill in the blank, sum of their measures is 90 degrees. So if you look at these two angles, this is angle A, is how this would be notated, and angle B are complementary angles because their angles add up to be 90 degrees. 32 plus 58 equals 90 degrees exactly. If you have two angles that the sum of their measures is 180 degrees, these are called supplementary angles. So number 7 on your vocabulary list, and you can see here that the angle CDE, sorry about that. And while we're on this example, let me just kind of explain how some angles may be notated. Here, you have angle A and angle B. This is how you would notate these angles. Over here, we don't want to just use angle D. You want to use all the points of that angle. So I would call this angle CDE, where the vertex D is in the middle of my angle name. So angle CDE is supplementary to angle EDF. And these two angles are supplementary because their sums, 101 and 79, equal 180 degrees. All right, your next vocabulary word is adjacent angles. Two angles that share a common side and a vertex and do not overlap are called adjacent angles. When two lines meet at a point, adjacent angles are supplementary. So looking at these two intersecting lines, we can see several examples of adjacent angles. So let's go ahead and pick out our adjacent angles. Please write this in your notes. Let's start with angle 1, and I'm going to notate that with one little arc here. Angle 1 is adjacent to angle 2, which is right here, because they share this common side and they share this vertex, and they do not overlap. So those are called adjacent angles. These two angles are supplementary because if you notice angle 1 and angle 2, they create a straight line together. So their sum is 180, and any two measures that are equivalent to 180 are known as supplementary angles. Adjacent angles are supplementary. Let's try to pick out other pairs of adjacent angles. Let's look at angle 3, and I'm going to indicate that with 3 arcs. Angle 3 and angle 4 are also supplementary adjacent angles. They are adjacent because they are right next to each other, and they are also supplementary because their angle measures would create a straight line and equal 180 degrees. There are a few more other pairs of adjacent angles in this example. You can see that angle 2 and angle 3 also form a straight line, making them adjacent and supplementary. And also angle 4 and angle 1 are adjacent. They're right here next to each other, and they also form a straight line, meaning that their sum is 180 degrees. So the most important thing you need to learn from this example is that adjacent angles are supplementary. They equal 180 degrees. All right, moving on. Vertical angles. We are on number 9 on your vocabulary list. Vertical angles. When two lines meet at a point, the angles that are opposite each other are called vertical angles. Vertical angles are congruent angles because they have the same measure. This symbol right here with the equal sign, you have a little squiggly mark above your equal sign, indicates congruence, and it is red is congruent too. So looking at your example, now your example in your guided notes is in black and white, so it's not color-coded so nicely like this. So if you have a highlighter and can color code, that would be excellent. You can see the blue angles, angle 1 and angle 3, this angle and this angle are vertical angles because they are opposite each other. So make sure you highlight or underline the word opposite. Your vertical angles are angles that are opposite. They are also congruent, which means they are equal. So using the symbol, you can see that angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4 because they are opposite one another. Now, in a math example, you may be given the measure of angle 1. Let's just say the angle measure is 63 degrees. Now, if the measure of angle 1 is 63, we automatically know the measure of angle 3 because of the vertical angle rule. Vertical angles are congruent, excuse me. So angle 3 would also be 63 degrees. Vertical angles are congruent. All right, now we're going to talk about lines that lie in a plane, and we are on number 10 on your vocabulary list, and let's start with plane. A plane is a flat surface that extends without end, and all of your intersecting lines, parallel lines, perpendicular lines will lie in the same plane for this unit. So a plane is just a flat surface that extends without end. Intersecting lines are two lines that meet at a point, and those are called intersecting lines. All right, moving on to number 12 on your vocabulary list, parallel lines. Two lines that lie in the same plane and do not intersect are called parallel lines. Please make sure you add this symbol to your notes. The symbol is just two vertical lines that are right next to each other. So looking at your example, I would say that line M is parallel to line N, and this is how it would be written and read. Another symbol, in addition to the two vertical lines, your parallel lines will be indicated with arrows that match, and that is your indicator that those lines are indeed parallel. All right, perpendicular lines are intersecting lines that form four right angles, and please make sure you include this symbol. The symbol is an upside down T, is how the symbol appears. You can see even the symbol has the right angle. So if I were going to talk about lines A and B, I would say that line A is perpendicular to line B, and this is how I would notate it. All right, corresponding angles. Corresponding angles are angles that occupy corresponding positions when a line intersects two other lines. When a line intersects two parallel lines, corresponding angles are congruent. So taking a look at this first example, you do not have these two examples in your notes, but you can just view the screen along with me. If I were to extend line C and line D, they would eventually intersect, meaning that these are not parallel lines. So if you have two lines that are not parallel, then they will not have corresponding angles that are congruent. So these corresponding angles are not congruent. If you look at this next example, lines E and F are parallel, and I know so because of these little arrows. This indicates that these two lines are parallel. If you have two parallel lines that are cut by something called a transversal, which we'll talk about next, then their corresponding angles are going to be congruent. So you can see that angle 3 and angle 4 are corresponding because they are in the same position. So these two angles would be said to be congruent. Angle 3 is congruent to angle 4. And we'll talk more about corresponding angles in just a moment. All right, on your vocabulary number 15, a transversal is a line that intersects two or more lines that lie in the same plane. So as you can see here, line A and line B are parallel, and they are cut or intersected by this other line, this third line, and this third line is called a transversal. And when you have a transversal that intersects two parallel lines, special angle pairs are formed, and that's what we're going to talk about next. If you have a highlighter, you may want to highlight these properties of transversals to parallel lines. These are very important. So we are going to start here with the alternate interior property. If you have two parallel lines as seen in this picture. These two lines are parallel, and the green line represents your transversal. So when you have two parallel lines that are cut by a transversal, their alternate interior angles are congruent or equal. So let's explain what alternate interior actually means. Alternate means opposite. Interior means inside. So using the meaning of these words, we can easily see the opposite inside angles are equal. So your notes aren't color-coded as well as on the screen. So if you have highlighters, this may be a great thing to color code. You can see here the purple shade, this angle, matches up with this angle. These angles are congruent or equal. They are inside the parallel lines. They're inside, making them interior, and they are opposites. So we call these alternate interior angles. And then I'll use a different color to show this angle is congruent with this angle. They are inside the parallel lines. Here are the parallel lines. They are inside the parallel lines, and they are opposite one another. So they are called alternate interior angles. Now, there is a special test that you can do to find alternate interior angles, and it is called the z-test. So let me show you. If you create a z with the transversal and the parallel lines, you can see that the opposite angles inside the corners of the z are your alternate interior angles, and they are congruent, as well as the angles on the outside of the z. And you can even make a backward z, and again, these angles are in the corners of the backwards z. So alternate interior angles are equivalent. Alright, moving on to the next one, alternate exterior angles are also congruent. So again, alternate means opposite. Let me change this back to black. Alternate means opposite, exterior means outside. So looking at your two parallel lines, we'll start with these pink angles here. You can see that this angle is on the outside of the parallel lines. And its opposite can be found over here, directly opposite on the outside of the parallel lines. So this pink angle is congruent to this pink angle. And then looking right here on this side, you can see this blue angle here is on the outside of the parallel line, so it's an exterior angle, and its opposite, also on the outside of the parallel line, is congruent to it. So these two blue angles are alternate exterior. You can also do the z-test with alternate exterior. This time your angles will be on the outside of the z. You can see it's on the outside part of the z. Your last type of special angles, when you have two parallel lines that are cut by a transversal, corresponding angles are created, and those corresponding angles are congruent. And corresponding angles are simply angles that are in the same position. So corresponding, there should be a P here, corresponding, just means the same position. So take a look with me at the pink angles. You can see, I'll name this 1, and you can see that 1 and 2 are in corresponding positions. They're both on the outside of the parallel line, on the top side of the parallel line, and you can see they're in the same spot. The blue angles are in the same position. Your black angles here are in the same position, and this dark purple color is in the same position. So the color coding really helps. If you have highlighters, I would really suggest going ahead and pressing pause and color coding your angles just like you see here on this video. So just to reiterate, properties of transversal lines. If you have parallel lines that are cut by this green line called a transversal, Your alternate interior angles are equal, they're congruent. Your alternate exterior angles are congruent, and your corresponding angles are congruent. All right, let's try some examples based on the things that we've learned. This first example is matching. So go ahead and try it before I actually give you the answers. Acute means less than 90 degrees. So just by looking at it, you can tell that angle A, oh, I'm sorry, that is not right. Let's erase quickly. It's actually this one down here at the bottom that is less than 90 degrees. Remember, acute means less than 90 degrees. Your right angle is always indicated by the little box here, so we know that's the right angle. Obtuse is this large angle up here. It's greater than 90 degrees, so that's definitely an obtuse angle. And then straight, of course, is your straight line. All right, example 2. For the lounge chair below, angle 1 and angle 2 are supplementary. So we know that these two angles are supplementary, meaning that they equal 180 degrees together. If the measure of angle 1 is 130 degrees, so let's write this in. Please write this on your example sheet. What is the measure of angle 2? Well, to find this missing measure, if you know the sum of the two measures is 180, all you need to do is subtract 130 to see what's left over. And so 50 is your leftover measure, meaning that the measure of angle 2 equals 50 degrees. And you can always check your work when added. Did these two angles equal 180? Yes, they do. All right, example 3, find the value of x. When given these kind of problems, you first want to see what kind of angle do I have. And this is a right angle, and it is indicated by the little box here. Right angles are equal to 90 degrees. So if we know that this angle here is equal to 62, how can we find this angle? All we need to do is take 90, because we know that's what they have to equal, subtract 62, and we get 28 degrees. So the measure of angle x is 28 degrees. And you can check your work. 62 plus 28 is that right angle of 90 degrees. These would be called complementary angles because they have a sum of 90 degrees. All right, example 4, name all pairs of adjacent and supplementary angles. Well, we did this earlier. Adjacent angles means that the angles are right next door to each other and they form a straight line. They equal 180 degrees, making them supplementary. So adjacent angles are supplementary. Angle 1 is adjacent to angle 2 because they're right next door to each other. They share this common side and this vertex, and they are equivalent to 180 degrees. So we need to write angle 1 and angle 2. Angle 2 and angle 3 also form adjacent angles because they're right next door to each other and they are supplementary. Angle 3 and angle 4 are adjacent angles. And finally, angle 4 and angle 1. These are adjacent angles and they form 180 degrees when added together. All right, example 5. Given that the measure of angle 1 equals 75 degrees, find the measure of angle 3. What I would do is, given the situation, is we know that angle 1 is 75 degrees. So write 75 degrees right there on your paper next to number 1. They want us to find the measure of angle 3, and you need to kind of analyze your picture and ask yourself, how are 1 and 3 related? Well, these are vertical angles because they are directly opposite of one another. And we learned earlier in this lesson that vertical angles are congruent. So if angle 1 is 75 degrees, then the measure of angle 3 is also 75 degrees. Vertical angles are congruent always. All right, your last example, maps. The map shows a section of New York City streets. Shown on maps often appear to form parallel or intersecting lines. Name two streets that are parallel and two streets that intersect. Well, you can easily find your parallel streets by looking for the arrows. Those are your indicators. So I see one arrow here and one arrow here. So 34th Street and 23rd Street are a pair of parallel lines. You can see that 7th Avenue has a double arrow, so it matches with Park Avenue, which also has a double arrow. So these are parallel lines. Streets that intersect, there's a number of streets that intersect. You could say Broadway intersects with 23rd Street. You could say Park Avenue intersects with 34th Street. There are a variety of intersecting streets in this picture. B says, given that the measure of angle 7 equals 68, find the measure of angle 1. So what I would do is go to your picture and actually write 68 degrees in for measure angle 7 right here. The second thing I would do is see, how are angle 7 and angle 1 related? How are they related? Are they related in any way? So let's go back through our vocabulary words and think about the things we know. We know that if we have parallel lines, which we do, 34th Street and 23rd Street, and they are cut by a transversal, which would be this line right here, which is Broadway. This is the transversal. We know three things. Corresponding angles are equal. We know that alternate interior angles are equal, and we know that alternate exterior angles are equal. So looking at these two angles, these are alternate exterior angles. I knew that they were alternate because they were opposite one another. I knew that they were exterior because they're on the outside of the parallel lines. They're not on the inside. 4, 3, 5, and 6 are on the inside, so those are interior. 1, 2, 8, and 7 are on the outside, so those are exterior. So 7 and 1 are actually alternate exterior angles, and because they are alternate exterior angles, they are congruent. So the measure of angle 1 also equals 68 degrees. Part C, find the measure of angle 6 and the measure of angle 2. Explain your reasoning. The measure of angle 6 is right here. So what I want to do is use the information I have. I can see that the adjacent angle is 68. It's right here. That was given to us in part B. So if the adjacent angle is 68, I can easily find 6 because I know adjacent angles are supplementary. They're equal to 180 degrees. So I'm going to do 180 minus 68, and that equals 112. So angle 6 must equal 112 degrees. The measure of angle 6 equals 112 degrees. And now let's look for the measure of angle 2. I'm going to switch to a different color now. I will use pink here. Alright, let's see how angle 6 and angle 2 are related. And if you look at angle 6 and angle 2, these are corresponding angles because they're in the same position. If you look at the 1, 2, 3, and 4 just kind of as a sort of like a tic-tac-toe board, the 2 is in the upper right-hand corner, and so is the 6. The 6 is in the upper right-hand corner. 5, 6, 7, 8. So you just want to find little ways like that to help you identify corresponding angles. The 2 and the 6 are corresponding angles, meaning that they are congruent. So if angle 6 is 112, that means that angle 2 is also 112 degrees because of corresponding angles. Alright, it is now your turn. You have a few questions to answer here. For 1 through 5, please identify Classify the angles as acute, obtuse, right, or straight using your definitions. For 6 and 7, use your definitions of complementary and supplementary angles to find the missing measures. And finally, for 8 and 9, for number 8, you're going to name all pairs of adjacent supplementary angles. And then for number 9, given that the measure of angle 1 is 75 degrees, what must be the measure of angle 2? All right, guys, good job today. I know that was a longer lesson, but I'm sure you guys did great. Please come tomorrow with questions for your teacher and all of your turn questions completed. Have a good night.